All right, today is Monday, January 14th, 1/14, and we are talking about probability today in our Precalculus class. All right, so let's start out with some vocab, and this is really like, what's the word for it? Low-level math. So today is a nice and easy day.
It's mostly on fractions and ratios.
Fractions and ratios. Make sure you know how to reduce those. Defining some terms that we'll be setting up tomorrow. Tomorrow is going to be a action-packed day with 6-2 because there's a lot of methods that I need to cover. Today is just making sure we're knowing what we're doing. Okay, probability. What is your definition of probability? Yeah, how likely something is to happen. So, how likely some random event is. And the key word being random, it has to be random. Like if I have a loaded dice, and by the way that you can make loaded dice is you put them in the oven for like 2 minutes, and then whatever side that is down, well, whatever side you have facing up will be facing up more likely. It's really fun to make loaded dice if you have some extra money.
Then you can cheat.
And then you can cheat, yeah. There's really cool archaeology that goes on where they actually find dice that like cavemen were using, and they can definitely tell that they're loaded. So cheating has been around for a while. So we always assume in our class that we're dealing with fair dice, and then eventually towards the end of it, we can start playing with unfair dice, and the math gets a little bit harder. But an outcome. What is an outcome? An outcome is this is what you get out of the event. So this is a repeatable possibility of an event. Very formal, but keeping this informal, I can say my event is throwing a 6-sided die. We know what that looks like. An outcome is rolling a 5. Rolling a 1, rolling a 2. I can get another 2, so that is an outcome. All right, and sample space. This thing, I'm gonna be using the word sample space over and over again. This is the set of all possible outcomes. And we'll be seeing sample space, especially tomorrow, a lot. But we're gonna be using sample space a little bit today. Let's talk about what I mean when I say probability. So I have the definition already there. It's the number of ways it can happen versus the total number of outcomes. And that total number of outcomes, another name for this is what? A word that we just defined up here? Outcome. Kind of, it's more specifically,
Sample space.
yeah, sample space. That's the same as your sample space. So that'll be pretty important for tomorrow's lesson also. But number of ways it can happen. So if I say I need to roll a 6, there's only one way I can roll a 6, and it's by rolling a 6. So the number of ways it can happen might be 1, it might be 3. It could be 3 if I say I want to roll a 4 or higher. So 4, 5, or 6, there would be 3 ways it can happen. All right, example 1. I'm rolling a 6-sided die, and I have a bunch of these in the closet if we actually want to play with this. What is the probability that I roll greater than a 5?
So it doesn't have to be 5? Or it has to be 5 and greater?
Yeah, that's a good question. Is it 5 and 6, or is it just 6? What do we think, Daisy?
What?
What is the probability that I roll greater than 5? When I say greater than 5, does that include 5, or is it not including 5?
Doesn't it include? I don't know.
So, yeah, and the answer here is it doesn't include, because greater than 5 is greater than 5 like that. Greater or equal to 5 would include 5, but greater than 5 does not include 5.
How do they say it other than just saying greater than or equal to 5? Isn't there another way to say that?
Yeah, so you can say, what would be another way of saying it? Roll 5 or greater, that's the same thing as saying, I'm actually blanking on how you would ask that to include 5. What is the probability that you... I'll have to come back to it, I don't know. All right, so what is the probability that you roll greater than 5? So that means you're only rolling a 6. How many ways can that happen?
1 out of 6. 6.
1 out of 6, yep. Answer here is 1 out of 6. And by the way, when I'm talking about probability, probability will always be between 0 and 1. Notice that 1/6 is between 0 and 1. If I have that on a calculator, 1 divided by 6, that's 0.166 repeating. This is approximately equal to 0.16 repeating. Your probability as a number will always be between 0 and 1. And I'm going to put this on the side margin. It's always between 0 and 1. If I turn that into a percent, that's always between 0 and 100%. So as a number between 0 and 1, as a percent, it's between 0 and 100. Usually we always just leave it as a fraction. We don't even have to worry about percents.
The percent for this one would be 0.16.
So this one would, if I was rounding to the nearest percent, this would be 17%. Because it would be 6 repeating, so you'd round up and you just say 17%. So by making it a percent, you move the decimal twice to the right, boom, boom, and then you get your percent. So far, so good. Good review of our elementary school career. All right, so we're spinning a spinner now. Each sector has an equal area, which is important. It makes it fair. If red was like 2/3 of it, then it would be unfair. What is the probability that I get blue? All right, you girls are going to be doing this one. What is the probability that I get blue? We'll count up all the possible, how many blues are there, and then how many were there total. Fraction 2 out of 8. Rochelle, you confirm, which reduces to 1/4. There it is. So 0.25, or as a percent, that is 25%. The ones that I will accept, these latter 3 I will accept. I don't accept unreduced fractions. It needs to be reduced as a decimal or as a percent. Usually I prefer just a fraction.
What does Khan Academy prefer? Do you know, Mr. Smith?
I think they'll accept all of them. Although they might not accept percents. They probably accept the left too. All right, in example 3, we're spinning the spinner above again, and each sector has same area. What is the probability that you do not get violet?
1 out of 8. Or would it be 7 out of 8?
Good question. Daisy, what do you think? 1 out of 8 or 7 out of 8? Yeah, because how many of these are not violet? Well, that's not violet. 1, 2, 3, 4, 5, 6, 7. 7 of those are not violet, so our numerator is going to be 7. Our denominator is going to be 8. And we'll just leave as a fraction, 7/8. I think that's like 88% or something like that. Was 7 divided by 8? Oh, yeah, 87.5, which rounds up to 88%. Yeah, that's example 3, and that's the end of our notes. So just simple probability. I promise that today was that easy lesson. Tomorrow will be a little bit harder. And that concludes the lesson. Any questions? All right, you can begin your summaries now.